So now, today what we're going to do is we're going to talk about relays. Why are they so important? Why there is so much of demand in the market on IM relays? And then we are going to talk about the features, and we are also going to talk about the resources like the catalogs. Learning objectives remains the same throughout. We're going to talk about the target markets, applications. We're going to also identify some of the relay brands that we have. We're going to define what is a relay, product design and features, and locate the resources. Now let's talk about target markets. So robotics, HVAC, building systems, solar, lighting, motion control, data communication, production equipment, servo motors. So if you see here, wherever there is an electrical circuit, there might be a use of a relay. So if you see all these markets, you have, these are all electrical circuits. So what you can say, what is a relay? If I have to break it down into very simple language. So in terms of electrical circuits, when we talk about relay, that helps in the current to pass through it. And the best common example of where a relay is used, what I can say, is the doorbell. Any switches that we have. We're going to talk about more, about that in much more detail. But just figure out when we are talking about relays that okay, it is used in switches. How does that circuit looks like? So all our explanation, we need to think about switches. We need to think about some other like electrical circuits where that can be used. Okay. Now going for applications. Robotic arm, again production lines, CNC lathe machines. So the green one is the CNC lathe machines. Control panels, motion control systems, HVAC and elevators. So these are some of the applications in which relays are used. Now sometimes what happens is, if the customer is designing for harsh or indoor applications, also we deliver high quality relays from state of the art production lines. Moving on next to relay brands, we have T Connectivity that produces relays. Our competitors are Bosch. Everybody would have heard the term Bosch. Then Products Unlimited, Midtex, Wilmar, Kilovac, Hartmann series. We have come across Hartmann series of products as well. Agastat, Axicom, OEG, Schrack, CII Technologies. TE has acquired most of the companies like Agastat. We acquired CII. Acquiring CII bought us a wide range of relays, contactors and solenoids. Kilovac as well, it's one of our brands. Kilovac is best known for high voltage relays. And if you talk about this company Midtex and Products Unlimited, they were first bought by CII. And when we acquired CII, automatically the Products Unlimited and Midtex came under T Connectivity. One information about Product Unlimited is the relays that are produced by the Products Unlimited, they are majorly used in the HVAC industry. Do you know that we acquired the automotive relay business from Bosch, and all the relays that are first sold the name of Bosch now are being sold under the name of T Connectivity. So these are some of the relay brands, out of which most of them have been acquired by TE. PNB stands for Potter and Brownfield, and Schrack, it's a leading industrial relay in Europe. Now it is trying to capture the market in US. Now let's talk about the relay organization. So we have the High Performance Relay Group, which is HPG, then the Relays Product Group, RPG. It has been divided, and we have some of the brands under HPG, some of the brands under RPG. Agastat, CII, Hartmann, Kilovac comes under HPG, which is High Performance Group. Now we'll talk about what is a relay. Simplest answer of relays are they are remote control switches. Okay, any application that requires a switch, that's where relays are present. What are switches? They are used to use a signal to open or close an electrical circuit. Now if you see an electrical circuit, it has to be in contact with everything so that the electric can pass around the circuit. Now what does this switch do? If a switch is in off position, and if you go into your room and the light bulb is not there, that means the switch is in off position. So let's talk about the circuit in off position. That means the circuit is not in continuous. There's a gap there so that the electricity is not being able to pass through the circuit and illuminate the room. Once you switch it on, or once you press the switch, it forms a stable connection so that the electricity can pass through the circuit and then illuminate the room, or help in powering on the applications or appliances. When you have a closed circuit, we have something known as a open or closed an electric circuit. What do we mean by an open circuit? If a switch is in the off position, that means what happens to the circuit? The circuit is open. If the switch is in off position, that means it is not joined. There's a gap. What does that gap do? It hinders the flow of the electricity. It will not make it as a complete circuit. Okay, the electricity cannot flow through that. Now when you switch it on, what it does is, from an open circuit it becomes a closed circuit. And what is the advantage of a closed circuit? The electricity flows throughout the closed circuit, and then whatever appliance you're trying to switch on, that will get switched on. Now, can be solid state or electromechanical. What do you mean by electromechanical? Electromechanical are mechanical parts somewhere where the electricity is passing through it. And solid state, it's one solid state of the switch, and it helps in closing the circuit. They have the single make contacts. Those are known as single make contacts, and they are hinged at one end, move in an arc and wipe. So that is the orientation of the contacts in the relays. That if you see here, they are hinged at one end and they move in an arc and wipe. Arc and wipe is nothing but the best example of an arc and wipe movement that I can say is the wipers in your car. Whenever the switch is turned on, so it moves in certain direction to close the circuit, and whenever the switch is turned off, the contacts move in the arc direction to open up the circuit. Now we have the classifications. So the Axicom is low signal dry circuit with 2 amps current carrying capacity. Then we have the OEG, PNB, Potter and Brunfled, and SRAC. Now for the power printed circuit board, there are 3 types: low, medium and high. Now the current carrying capacity of the low power PCB or power printed circuit board is 2 to 10 amps. Medium is 5 to 15 amps and high is 10 to 30 amps. These are nothing but the current carrying capacity of the relays. Now we also do have the general purpose panel plug-in, the dry 30 amps, and the T connectivity contactors, which is 20 to 150 amps. So see, what do we offer? We offer the current carrying capacity from 20 to 150 amps. The contactors carry higher current. Before we go into how an electromechanical relay works, so if you see here, the electromechanical relay has contacts, insulation, armature, spring, the core and the coil. We are going to go one by one of all the components. Let's first talk about the coil. The coil is nothing but an assembly of one or more windings. It is usually a kind of like a wire which is wounded over an insulated iron core. So when we are talking about the electromechanical relay, we need to understand of electromagnets, how the electromagnets are designed. Whenever you hear the term electromechanical or electromagnet, there's nothing but we need to actually imagine that you have a solid object around which the wires are wounded, and that solid object would be made up of insulated iron core. So the combination of the insulated iron core over which the wires are wounded is known as a coil. Now, the armature. Armature is nothing but the moving part or the moving magnetic member of the relay. Armature is derived from the word arms, and arms does what? It supports, right? So the armature here is the moving magnetic member of the relay. So now, once that electric current is passed through the coil, the core becomes magnetic. That is the principle of electromagnetism. In electromagnetism, we cannot find an actual magnet, but when an electric current is passed on through the coil over the core becomes magnetic. If the core becomes magnetic, what it does is it causes the armature to close the contact surface. Now what happens if you close the contact? Current passes and the circuit becomes a closed one. We spoke about core, coil and armature. Now insulation, we know what insulation means. It electrically isolates the contact arm from the spring. Now, a role of the spring here. It helps in the pushing and the pulling of the armature. Now, if the electromagnet is not energized, so let's say if the coil and the core is not energized, it is not an electromagnet. So, the spring returns to its normal position. So, once the spring returns to its normal position, what happens to the contacts? They open up. So that becomes an open circuit. When it is energized, it pushes the armature, contacts get in touch with each other, and it is a closed circuit. Now we have the contacts. What is contact? It is the current carrying part of the relay that engages or disengages to form an open or a closed circuits. Okay, all this is done just for the contacts to get in touch with each other so that it forms a closed circuit. And when it is not energized, the spring pulls back the armature wherein the contacts are not in touch with each other. Now we are going to talk about relays, timers and contactors. It's the same thing. We have the coil, the core, it becomes energized, it pushes the spring, insulation, contacts, close and open, okay, and then it becomes a closed circuit through which current can pass. With that, we come to the working, or we come to the different types of relays that we have. This is a relay. This is known as the KRP series relay. This is again electromechanical relay. So if you see here, these are the contacts. These are the contacts. You have the springs. You cannot see the springs clearly here. This is the armature arm. The spring would be here, and then it gets touched with the contact to form a closed circuit. Now we have the solid state relay, including I/O modules. I/O means input and output modules. See, if you see the solid state, we do not have any mechanical movements in here. We have the mechanical movements in the electromechanical relay. In the solid state, we do not have mechanical movements. So how it is achieved? It is achieved by means of electronic components. So we have circuits inside of the solid state relays as well. So these are all electronic components, and without the use of moving parts, that is how the solid state relay work. Doorbell switches are electromechanical because they cannot be pressed and left it like that. They will come back into their normal shape. And so that's the perfect example of electromechanical switches. Solid state switches, you can do our normal switches as solid state switches. For electromechanical, the simplest way to understand is there would be a mechanical arm which would be in motion, like the armature. the easiest way to identify is you have a spring in an electromechanical relay. When this becomes energized, it pushes it and the contacts get in touch with each other. When it is not energized, the spring, what it does is it returns to the normal position, moving it as in an open circuit. This is a mechanical. Only thing to take care is wherever there is movement of a mechanical arm, it is electromechanical. Coming back to solid state, you do not find any mechanical arm here. These are all electronic components inside which makes that relay to work. That is why it is known as solid state relay. What we are going to talk about is, we are going to talk about timers now. Timers is nothing but a relays with internal timer functions. If you want to time it up, it is nothing but relays with internal timer functions. It generates delays that can vary in time and quantity. Okay, the best example for a timer application would be rocket launch. So once the timer hits 0, we want the rocket to be launched. Okay, building systems controls, elevators, amazing example. HVAC, heater, door, fans, pumps, these are for timers. Test equipment, welding systems, car washing equipment. We all know that, when you go to the automated car washing equipment, based on the timing. Now we are going to talk about contactors. Contactors are nothing but they're similar to relays, but that switch a much heavier current. So the difference between a relay and a contactor is only the current. Let's see the current carrying capacity, or much greater than 35 amps. Typically have double make or double rake contacts. Now the contacts move in linear motion. Linear motion is a straight motion. That is what contactors do. Very simple. Relays for low current, contactors for high currents. Okay, this is a rough diagram of a contactor. A contactor typically consists of a solenoid or an E-core. Whenever you hear the term solenoid, it is DC. Whenever you hear the term E-core, it is AC. Direct current and alternate current. So direct current is nothing but represented by the term solenoid here, and AC, alternate current, is represented by the term E-core. We do not have the labeling to this, but if you see the arms near the spring, these are the contacts, the armature or the spring, then we have the core. It's almost the same, okay, but the orientation is different and it is used for a higher amounts of current. Let's talk about relays, timers and contactors in a bit more detail. How it works. So our thermostat operates on 24 volts AC, but the motor that controls the thermostat operates on voltages ranging from 120 volts to 600. It is very obvious that when a part is in motion, what is generated? Heat is generated. Motor is constantly in motion, right? So the temperature of the motor would be more rather than thermostat. So that's what is being shown here. Now unless this high voltage is isolated from thermostat, the thermostat will be destroyed and user could be hurt. If the high voltage is not isolated from the thermostat, because if you see thermostat operates on 24 volts, whereas the high voltage motor operates on 120 volts. Unless the high voltage is isolated from thermostat, it could destroy the thermostat and destroy the equipment as well. Moving forward, we are going to talk about the relay types. So we have the general and purpose relay, the signal relay, mill relay, automotive and power and relay contactor. We're going to talk about all this individually. So let's start. Let's talk about general purpose relay. The general purpose relay are used for, these relays are used for general activities. Okay, it should not be subjected to extreme harsh environments. It can work better in general applications. Signal relay, as the name suggests, what does it transfer? Correct, it would transfer signal, and they have low current ratings, just low current ratings, and they are used in multiple signal applications. Those are about the signal relay types. Now, mill relay is often referred to as mil spec. Electromechanical and solid state relays manufactured to military standards. So mill relay means we have electromechanical and solid state that are manufactured to military standards, as per the military standards. Then we come up to power relay and contactor. So the current carrying capacity is from 10 amps to higher. Now, automotive. What happens is we need to cannot put the general purpose relay in automotive because of the environment that the relay is in. Okay, if we have vibrations and all, it might not give you the optimum performance. Now let's talk about common contact forms. We have the form A, form B, form C and form D. Form A, design SPST, no sequence. Form B, design SPST, no sequence, break 1. Design SPDT, sequence, make or break. So what I'll do is I'll try to download a good video on the common contact forms, because looking at this diagram you'll not be able to understand. For the relay selection criteria, we have the contact switch rating, current rating. So if you see here the selection criteria, what's the current rating? What's the mount and type? Is it the PCB mount or the socket panel mount? What coil are you using? An AC one or a DC one? Number of poles, 1, 2 or more poles. Now we do have the resources, so please try to copy paste or save this link. It will be very much useful.